Okay. Application of derivatives, not graph part. Huh? Application of derivatives, simple part. Today we can finish that. Application of derivatives. So we have real applications. I'm going to discuss that. Okay, right topic, applications of derivatives. Applications of derivatives. Here this is very simple part. Application of derivative, very simple part. Definitely question number 14 part B will be application of derivative part. Most probably 7 or 6 marks out of 100 you will get. 7 or 6 or 7 mark out of 100 you will get for pure mathematics paper. Then here we mainly focus about real applications. Real applications. Then in day-to-day life, we think about maximums, maximum and minimum. Maximum and minimum, especially we say local maximum, local minimum. Local maximum and local minimum. So two different things. So when you consider here this type of graph, we say it is maximum type graph, local maximum type, here local minimum. So here this point we say local minimum, here this point we say local maximum. Local maximum and local minimum. Okay. So when you sketch a tangent here, then it is surely parallel to x-axis. When you sketch a tangent here, that is surely parallel to x-axis. No? And also, it goes like this and it turns. Then this maximum point we call turning point as well. And minimum point also we say turning point. Both are turning points. So maximum point here at the maximum point when you sketch a tangent, that is surely parallel to x-axis. At the minimum point also surely parallel to x-axis. So when you consider here this point, if you sketch a tangent like this, and when you consider this point and if you sketch a tangent like this, so here positive gradient and here negative gradient. Obtuse angle, no? Negative gradient. Here acute angle, positive gradient. Here zero gradient. Here negative gradient. And here zero gradient. And here negative gradient. That's how gradient varies. Okay. So when you consider point somewhere here, you sketch a tangent and you sketch tangent here. Here positive gradient, here zero gradient, and here negative gradient. Therefore, here gradient varies negative to positive, and here gradient varies positive to negative, and here negative to positive. Then that's how we identify a maximum and minimum. Here this shape we call concave down, here concave down, here concave up, here concave down, and here concave up type. Then here mainly focus about gradient. No? So in differentiation we know differentiation represent gradient. Therefore by differentiation we can analyze this maximum and minimum points. So here these two are, especially we say turning points, and again we have further turning points and inflection points, both we have. But in applications of derivatives we mainly focus about local maximum and local minimum. That's the thing. Really simple thing. Okay. Then here differentiation part very small. Then we have to do one differentiation of the function. Then further part just mathematics Just mathematics, okay? Okay, just write down applications of derivatives. Okay, try this way. Try this way. Okay, write down. In day-to-day life, there are some variables. In day-to-day life, there are some variables which are varies with another variable or variables, another variable or variables. Example, volume of a cylinder varies with radius and varies with radius and height. Varies with radius and height. Example 2. Cost function of a sphere varies with the material. Okay, 2 examples enough. So now see, now you identify there are some variables or some quantities that varies with another quantity, no? So in such case, we have to maximize something or minimize something. So if we need to maximize volume, we have to do something. If we need to minimize cost, we have to do something. Then those things we analyze by using differentiation. Okay, write down. To maximize or minimize some quantity, differentiation is applicable. Okay. Now you sketch this one. Sketch the diagram. Here we call local minimum and here local maximum. Local mean only one point it happened. Local maximum, local minimum, gradient varies, positive to negative gradient varies. Here negative to positive gradient varies. Gradient varies positive to negative through 0. And here gradient varies negative to positive through 0. Here positive to negative through 0, here negative to positive through 0. Okay. Now further you consider, here you go from left to right. You go from left to right. So when you go from left to right along this curve, here increasing and then decreasing. Okay. Here decreasing, then increasing. Decreasing, then turn and increasing. Here increasing, then turn and decreasing. Okay. That's how we analyze. Increasing, decreasing. Here gradient positive, huh? Positive, negative, negative, positive. Okay, write down. Write down. The above local maximum or local minimum, the above local maximum or local minimum, the above local maximum or local minimum can be identified by differentiation. By differentiation. Because by the derivatives, by the derivatives we can analyze gradient of the tangent, gradient of the tangent, gradient of the tangent drawn to the curve at certain point, Therefore, by the gradient, increase in functions, decrease in functions, increase in functions and decrease in functions can be analyzed. Increase in functions and decrease in functions can be analyzed. And also critical points within bracket turning points or point of inflections, critical points within bracket turning point or point of inflections can be analyzed. Next line. By the second derivative, concavity can be analyzed. Okay. Now you sketch this one. See this. Here I told this before. Here local maximum, local minimum. Here increasing inflection, and here decreasing inflection, These 4 points we call critical points. And these two we say turning points. Altogether critical points. These two we say turning point. Sketch with me. Here, point of inflections. So when you sketch a tangent here, that is parallel to x-axis. When you sketch a tangent here, that is parallel to x-axis. When you sketch a tangent, that is parallel to x-axis. When you sketch a tangent, that also parallel to x-axis. Therefore, all these cases gradients are 0. Critical point. Critical point. Okay, we have 4 cases. And here this is specially local maximum, here local minimum, here increase in inflections, and here decrease in inflections. And these are critical points. These are critical points. Gradient of the tangent drawn to the curve at critical point is 0. Is 0. That's the thing. Gradient of the tangent drawn to the curve at critical point is 0. That's the thing. Okay, write it. That is about critical point. So in graph also we need to analyze them. But in application of derivatives, we need to analyze local maximum or local minimum only. Local maximum or local minimum only. Okay. Right? Let's sketch and write this. This is very simple marker. Application of derivative, really simple type. So today we're gonna discuss past papers as well. Okay. Now same time use put this on as well. Take this. So here this type concave down, here this type concave up. Concave up, concave down. Here concavity we check by second derivative. Concavity. Can be obtained by f double dash x, second derivative. Here for concave up case, f double dash x positive. Concave down case, f double dash x negative. F double dash x negative. Okay, put that on as well. Concavity. Concavity. Here concave down, here concave up. Concave up we obtain by second derivative, concave down also we can obtain by second derivative. Then up case positive second derivative, down case negative second derivative. Okay, put them. Okay. Now we have increase in functions. Here there are three types. These are increase in functions. For all cases, f dash x greater than 0. F dash x greater than 0. Then as x increase in, y increasing. As x increasing, y increasing. Here this case, especially f double dash x positive, and for this case, f double dash x negative, and here this case, f double dash x 0. Then constant gradient, then when we differentiate gradient again, we get 0. Then constant gradient, second derivative will be 0. Then here concave up, concave up gradient, second derivative positive. Then here concave down, second derivative negative. Then all three cases, first derivative positive. These are we call increase in functions. Increase in functions. Then here as x increases, y also increases, no? Okay. Then similarly we have decrease in functions. So here there are three cases again. Here three cases. Then for all case, f dash x negative for decrease in function. Then as x increasing, y decreasing, no? As x increasing, y decreasing, decrease in function. And for this case, especially f double dash x concave up, no? Positive. And for this case, f double dash x 0. And for this case, f double dash x negative. Then we have two different function types, increase in functions, decrease in functions, increasing and decreasing. So in same single function, there can be increase in region and decrease in region. Increase in region and decrease in region. Then increase in case, as x increases, y increase. Okay. Then for that case, positive gradient. For decrease in, negative gradient. That means second derivative negative. Then here concave up, concave down. Concave up, positive second derivative. Concave down case, negative second derivative. Okay. Put them. Okay. Write them. Okay. Now, next part. See this one. You consider maximum and minimum. So take this point, corresponding x coordinate, x equal a. Then here take this point, x equal a plus delta. Delta means very small value. And take this point, that is x equal a minus delta. Okay. Then when you sketch a tangent here, we know that is parallel to x-axis. Here obtuse angle, and here acute angle. Therefore, when you consider dy by dx or f dash x at x equals a, that is 0, no? 0. Then dy by dx at x equals a minus delta, positive. greater than 0. Then dy by dx, x equal a plus delta negative. Then similarly here, you consider x equals a, here x equals a plus delta, here x equals a minus delta. Here parallel to x-axis, here acute angle, here obtuse angle gradient. Therefore, dy by dx, x equal a minus delta negative. Then dy by dx, x equal a 0. Then dy by dx at x equals a plus delta positive, no? A plus delta positive. Delta means very small value. So anyway, at that point, gradient 0, then some point away, here right hand side positive and left hand side negative. Here right hand side negative, left hand side positive. Positive to negative variation, negative to positive variation. That's how we analyze maximum and minimum. So here sign variation of the derivative. Okay, put it sign variation of the derivative. Of dy by dx. Dy by dx. Because of this sun, you can find critical point. Then derivative 0 point we call critical point. You better write here, better to highlight this sun. First derivative zero points are critical point. First derivative 0 points are critical point. Then here especially a value we call critical value. Here x equals to a, no? We say that is critical value. X equal a, that means derivative 0 position. X equals a position, critical value, then corresponding point, critical point. That's how we analyze. Do soon. Okay, then first derivative 0 position, critical point. Huh? Okay. So when you are doing application of derivatives, you have to identify critical point first. So that point belongs to maximum or minimum, no? Belongs to maximum or minimum. Then first of all, you have to identify critical point. Then critical point we obtain by checking derivative, no? Then derivative 0 position. Then first step, you have to differentiate the function, then equate to 0, find values, that is critical values. That means x values, critical values. That value we can substitute the function, then we can get the point. Then we can get the point, that's the procedure. So again, before differentiating the function, we have to convert that into single variable like y equal fx. Okay, no multivariable functions we analyze, only single variable functions we analyze under A levels. Okay, write down. For applications of derivatives, follow the following procedure. First one, obtain the function which should be maximized or minimized. It should be maximized or minimized. And then convert into single variable function. Step 2. Differentiate the function. And find derivative 0 positions. Derivative position. Next step, check sign of the derivative. And identify minimum or maximum. Okay, now I'll do this for simple function. You consider y equal x square minus 2x minus 3 function. So differentiate this dy by dx. Here 2x minus 2. Then check dy by dx 0 point. Then 2x minus 2 0. X equal 1. Here we call critical value. Okay. Then here critical value, get corresponding point. Substitute 1 square 2 times 1 minus 3, that is minus 4. Then here 1 minus 4 is the critical point. Therefore, by these two you say 1 comma minus for critical point. Critical point. Here this is single variable function. So now you check dy by dx sign. So you have to check with this critical value. X equals 1, less than 1 and greater than 1 case. X less than 1, x greater than 1, dy by dx sign. So here this is dy by dx now. So you take this one, greater than 1 value, here for greater than 1 value, dy by dx positive. And here less than 1 value, here dy by dx negative. Na? Then negative to positive variation we say minimum. Na? Negative to positive variation we say minimum. Here negative at 1, 0, here positive acute. Then here local minimum. Therefore, 1 minus 4 is a local minimum. Local minimum. That's how we identify. So by using quadratic type also we can analyze same. By using differentiation we can analyze critical points. Okay. Do that example. Do that example. Okay. Now let's start the questions. Take your past paper collection. Take past paper collection. Now I told you question number 14 pure paper part B will be application of derivative class. First identify the thing. Take 2024 part B part. 2024 part B part. Just read it. Don't do. Just read. Just read. A cylinder with top and bottom is made to have volume 1024 pi cubic centimeters. Then volume given fixed volume. Let R be the radius of the cylinder, so that the total surface area S of the cylinder given by S equal 2 pi 1024 divided by R plus R square. Then thereafter show that S is minimum when R equal 8. Then we have to analyze minimum. Then at the minimum we have to differentiate and equate to 0. That's the. Then when you are reading this question you see what has to be minimum or what has to be maximum. So here we have to minimize S. Therefore S function S given in terms of R, then it is single variable function. No? S varies with R. Then you have to differentiate S with respect to R. You have to differentiate S with respect to R and equate to 0, find critical value and check the sign. That's it. Now just read 2023 part B part. Just read. Analyze the thing. Huh? It is required to build a fence of lawn along diagonal of rectangular region of area k square meters. Then area given mean it is fixed. Then one side given x. You have to show that L squared equal x squared plus k squared over L x squared. So using general mathematics you can show. And hence show that L is minimum when x equals root k. We have to find minimum value of L. Then you have to differentiate L with respect to x now. The function given single variable now. Then you differentiate L with respect to x and equate to 0 and find critical value. And we have to show that is minimum by checking the sign. No? By checking the sign you can so that it is minimum. Then go to 2022 part B. The shaded region given 45 square meters. That means area fixed. Area fixed. Then rectangular part has removed. Show that the perimeter of L. Perimeter given L equals 6x plus 54 x. That is perimeter. Find the value of x such that L is minimum. Then you have differentiate L with respect to x. No? Differentiate L with respect to x and equate to 0 and you can go further. That's how we do. Then again, last analysis. Go to 2021 part B part. Part B part, the shader region. Put there B. The shader region S of the adjoint figure shown a garden consisting of rectangular two sectors. So last line, S is given, show that the perimeter P is of S given by 2x plus 72 of x. Then perimeter function given. We have to minimize perimeter. Then P single variable, you differentiate P with respect to x and equate to 0 and you can find corresponding x value. Very simple question. So very simple mark here. Definitely you get at least 6 and maximum 7. Okay. Then let's start from 2024 A-level question. Okay. Read and start sketching. (2024) Part B part. First you sketch. 'cylinder, here cylinder, top and bottom is made to have a volume of 1024 5 cubic centimeters. Let R be the radius of the cylinder. Let R be the cylinder radius. You take height simple h. Then volume you can write pi r squared h, 1024 pi. Simplify, h equal 1024 over r squared. Show that the total surface area. Then surface area, here two circular base, pi r square times 2 plus here outer surface area, here this part, 2 pi RH, 2 pi RH, 2 pi RH, 2 pi r squared, 2 pi RH value, here you take from here, 1024 divided by r squared. Then cancel r. 2 pi r square, 2 pi 1024 over r. Then take 2 pi outside. Here 1024 divided by r and here r squared. So radius r positive. Radius r positive. Then here the function Here this function, area function, surface area function, variation with respect to R, surface area. Here this is general mathematics, general mathematics, not calculus, just general mathematics. Then general geometry you apply and obtain the relation. Now thereafter, show that S is minimum when R equal 8. Then we have to find minimum S value. No? Therefore, you differentiate this one, differentiate S with respect to R, differentiate this. Then ds divided by dr, here 2 pi constant, no? So 1024 divided by r, here this derivative we say 1024 divided by r squared minus r squared derivative 2r. No? Then I told you to remind 1 over x derivative minus 1 over x squared. Then here 1 over r derivative minus 1 over r squared. Here we have constant. No? Directly apply them. So now here it is. Now you better to simplify this. Then ds divided by dr, simplify, get common denominator, take 2 outside. Then 4 pi, here r cube, this goes to here r cube, 512 divided by r squared. Here 4 pi, r cube minus 8 cube over r squared. Now you take ds divided by dr 0. Then to get maximum or minimum value, you have to consider derivative 0 position. Here we need to minimum s. Here for minimum s. For minimum s value, ds over dr 0. Then here 4 pi, r cube minus 8 cube over r square 0. Then r cube equal 8 cube. Then we get r equal 8. R equal 8. Very simple. You obtain the function, convert into single variable, differentiate, simplify and equate to 0, find the value. Okay, that's the procedure. Thereafter you check sign of the function. Sign of the function close to r equal 8. Sign of the function close to r equal 8. Then sign of ds over dr. ds over dr. About r equal 8. Here 8 greater than 8, less than 8, but that is positive. Then you take this one, that is ds over dr. No? Then r less than 8, this part negative. R greater than 8, this part positive. Then negative to positive variation minimum. Therefore, at r equal 8, s is minimum. At r equal 8, s is minimum. That's how we do. Very simple part. You follow that procedure. Obtain the function, convert into single variable, differentiate, simplify, equate to 0, and check the sign. That's the procedure. Okay, again see the procedure. Here you have to obtain a function. That means we have to minimize s now. We have to obtain function that belongs to S with single variable. So using general geometry and mathematics, you have to obtain that. Convert into single variable. Then we have to minimize this one. Then to get minimum value, differentiate it. Then here, simple differentiation step we have. No advanced differentiation, we just simpler differentiation type. Then differentiate, simplify, and equate to 0. Then find corresponding critical value. No? Thereafter you check the sign. That's it. Okay. Then 2023 part B. 2023. Do alone. It is required to build a fence with along a diagonal of rectangular region of area K. Then K value you consider as a constant. K value constant area, okay? That one varies. So we have to minimize length L. Now, use general geometry. So if you have any doubt, do with me. Here x in meters, here L, capital L in meters, here rectangular shape, no? Take here y. Then area K square meters equal x times y. K square, no? Sorry, K. X times y. Then xy equal K. Then y squared equal by the Pythagorean theorem, or apply Pythagorean theorem, L squared equal x squared plus y squared. Then y mean K divided by x. Now you can take x square equal K square plus divide by x square. That's the function. L square equal L square equal x squared plus k square divided by x square. Show that L is minimum now. Now you have to differentiate that. No need to get square root. By taking similar relation, you can differentiate. Identify k is a constant, okay? K is a constant, x is a variable, L varies with L varies with x. Then we have differentiate L with respect to k. Differentiate L with respect to k, no? Continue. Here this is general mathematics. These are general mathematics, not advanced mathematics. Differentiate L with respect to x. Then L square derivative, function of function, 2L times dl divided by dx, x square derivative 2x plus k squared of x square derivative, k square times x to the power minus 2 derivative minus 2 x to the power minus 2 minus 1. Simplify to x minus k k squared over x cubed, then x to the power 4 minus k squared over x cubed. Now take dl divided by dx0 for minimum L. Therefore, x to the power 4 minus k square of x cubed 0, then solve this. X to the power 4 equal k square, you say x equals square root k. No need to put plus or minus. Here no need to put plus or minus because this is real application. Then real application x value always positive. Don't put plus or minus root k. Okay, we can directly write x equals root k only because real application x is positive. X means length, no? Then length always positive. That's why we can take positive value directly. Okay, that is critical value. Then check dl divided by dx sine. Then here take critical value root k. Then about this point you have to check. About this point you have to check. Then if you consider here less than root k, here negative. Greater than root k, this part greater than positive. Then minimum. Therefore, when x equal root k, L is minimum. When x equals root k, L is minimum. L is minimum. That's how we do. '23, that is. Thereafter you can move to 2022. When you take dl divided by dx0, this term, full term will disappear. Then don't worry about this L term. Don't worry about that. L times 0. Okay. Then you go to 2022 question and start. Okay. Here we check dl divided by dx sine. Okay. dl divided by dx sine. We have to show that that is minimum. So here critical value. So you need to consider critical value. Here cross set you consider. Here k greater than root k, x value greater than root k, x value less than root k. Okay. Here x equals k, we know x equals k, it is 0. X equal root k, it is 0. Then you're going to check dl divided by dx sine. dl divided by dx mean here this one. L times dl divided by dx. Here L mean length, no, positive. Positive. L mean length, positive. Then we don't worry about that one. Then when x value greater than root k, x value greater than root k, here this part greater than k square. No? Here positive part, positive. When x value less than root k, here this is small. No? This part small than k square. Therefore, it is negative. Then negative to positive variation minimum. Negative to positive variation minimum. That's how we analyze. Start 2022. Do alone. Here all variables are given. Variables are given and the relation already given. Then that means path given. Then you have to go along that path. That's it. 2022. Part B. Here the figure. If you have in doubt, do with me. Others do alone. Y, X, to Y. Then here area fixed. 45 square meters. Then 45 equal here 2y times x. 2y times x. That means times 2 plus x times y. Then 45 5xy. Here y equal 9 divided by x. Take this relation. Now the perimeter L, here 2y, 4y, 5y, 6y. Here 3x, 4x, 5x, 6x. Here the perimeter. Now you can convert into single variable. No? Then you convert that into single variable. Now by this you can replace y. 9 of x, 6x. Now 6x, 54 of x. Here it is. Then x, y both are positive values. Here the function. Now L perimeter we have to minimize it. Now that is in single variable. Then you differentiate that. Differentiate the function now. Then check dl divided by dx. 6x derivative 6. 54 over x equal 54 over x squared. Then take 6 outside. X squared minus 9 over x squared. Then you have to solve dl divided by dx to 0 to get minimum. Therefore dl over dx 0. Here 6 x squared minus 9 over x squared 0. Then x squared equal 9, x equal 3. Here no need to write plus or minus 3 because x positive. Since x positive, x means length, no? Then since x positive, don't worry about getting negative values. Okay, but just pure mathematics we get plus or minus 3. In pure mathematics we get plus or minus 3. In algebra we have to take that. But here application, side length positive, then you can consider only positive values. Then x equals 3. Now you check dl divided by dx sine. about this x equals 3. Here 3, 3, less than 3, greater than 3. Then here you have to stop at 0. Then greater than 3, here this part positive. Less than 3, here less than 9, no, negative. Then negative to positive variation minimum. Therefore, at x equal 3, L is minimum. L is minimum. Find the values of x such that L is minimum. That's it. So while doing that, so we have to know some geometrical things. So I'll just revise it. Take this. Here when you consider arc, and here a sector, take this angle alpha radius r, then here arc length is equal r theta. R theta means 2 alpha. I take here theta r theta. Then here area half r square theta. You need to remember these geometrical relations, okay? Here when you consider a sphere, or here take circle, then here radius r, we know that one, pi r square, no, area pi r square. Here a sector, you know square and rectangle, here xy, here area xy. These are general things. No? Now you consider here a sphere, radius r, then volume 4/3 pi r cube, and area 4 pi r square. You have to remember this. Huh? For sphere, surface area 4 pi r square. Then volume 4/3 pi r cube. 4/3 pi r cube. Now here a cylinder, radius r, height simple h. Here volume pi r squared h, area here 2 pi r h. Here 2 pi r h and pi r square twice. And here a cone, height h, slant height L, radius r. Then volume 1/3 pi r squared h, surface area, here curve part pi r L plus pi r squared. Here pi r square, full surface area. Here pi r L, pi r square. That is a cone. Okay. These geometrical things you have to remember. You have to remember that. Huh? Okay, go to 2021. Go to 2021 A-level question. Continue. 2021 question. part B part only. So here the figure. Y, X all are given, angle 3 pi over 8. The area 36 square meters. Then 36 equal, here rectangle XY, here sectors, 2 sectors, 2 times half, R mean X, no? X square, theta mean 3 pi over 8. 3 pi over 8. Then 36 XY, here 3 pi divided by 8 X. Then Y, take Y, 36 minus 3 pi divided by 8 X, no? Now divide by X. Here it is. Here X squared 3 pi over 8x. This is Y. Then perimeter P. Perimeter, here Y plus Y, 2Y. X plus X, 2X. Here R theta. Here R theta. R mean X. Theta mean 3 pi divided by 8 times 2. Two y plus 2x, 3 pi divided by 4x. Now put this y here. Y equal 36 of x, 3 pi x divided by 8 plus 2x, 3 pi divided by 4x. Now here 3 pi divided by 4x you can cancel. Then here 2x, 72 of x, that is perimeter. Then here x greater than 0. That is general geometry. First write area relation, then write perimeter relation and manage it to get the result. Now here we have to minimize P. We have to minimize P when let's find that. P, then differentiate dP over dx, 2 minus 72 over x squared. Here when x equals 6, when x equals 6. Now simplify. Take 2 outside, x squared minus 36 divide by x squared. Now dP over dx equals 0. To get minimum value, minimum P. Then simplify. 2x squared minus 36 of x squared 0. Then x squared 36, x equal plus 6, x positive value, no? Then x value 6 only. Now you have to show that that is minimum. Then dP divided by dx sine, dual on, here 6, 6 less than x, greater than x. Here we have to check sine of dP over dx. Here you have to take this. Then less than 6 value negative, greater than 6 value positive. Here positive, negative. Here you better to stop at 0 because x positive no. Then negative to positive variation minimum. Therefore at x equals 6, p is minimum. At x equals 6, p is minimum. Here we follow one simple technique. First get in function, then differentiation, and solve dy by dx 0 and check the sign. That's it. Very simple procedure. Okay, then 2020. Part BB. Here dustpan shown in the figure and all the values are given. It's given that its volume given. Here the figure. So here volume given 4500 cubic centimeters, that is x squared h 4500. Then h equal 4500 divided by x squared. Then surface area given s equal 2x squared plus 3xh. Surface area given, na? No need to find. Both are given. No need to find. Show that s is minimum when x equals 15. Now you have to differentiate this. Before that you convert this into single variable. 2x square 3x h mean 4500 divided by x squared. Then single variable function 2x square 3 times 4500 divided by x. Here single variable function. Now differentiate x by x. Here 2x square derivative 4x. 3 times 4500 divided by x squared. Here 1 over x derivative minus 1 over x squared. Then simplify little. X square 3 times 4500 x squared. Now you take 4 outside. Here x cube. No? Now 4500 divided by 4. Here 125 times 3. 125 times 3. 3375. So here values are all, answers are given. No? Answers are given. Okay, here answers are given. Then you follow procedure dx divided by dx equals 0. Therefore, x cube 33750, then x equals 15. x value 15. මෙතනද අමාරුවෙන් මේ x cube ගේ value හොයන්න එපා. 15 දීලා තියෙනවා. ආය අමාරුවෙන් ඒක හරිද කියලා හොයන්න යන්න එපා. ඒක අරගෙන check කරලා බලන්න එච්චරයි. x equals 15. Then ds over dx sign, you check this sign. Yeah, about this 15 value you have to check. Less than x, greater than x, 15. Then less than 15 here negative, greater than 15 positive. Then negative to positive minimum. Negative to positive minimum. Therefore, when x equals 15, s is minimum. S is minimum. Complete? Okay, then you analyze that all sections are similar types. Okay, first we have to build the function, then we have to convert that into single variable, then we have to differentiate and equate to 0, then find critical value. Okay, then finally you have to check sign of the derivative. Okay, 2019 A-level question. Part B. Part B. Here, 2019 A-level question, Part B. Here, that shape we call especially first term, that is made by removing a cone by a cone. Okay, that type we call first term. Then you remove cone by a cone. Here, full cone, radius 2r. Here the other cone, radius r. Then it is bisected now. Then here 30, this length 30, this length 30 centimeters. Then find height. Height equal, here 60 square, 60 square minus 2r square root is the height. Then here take 2 outside, 2, 900 minus r square root. Height. Here h, here h over 2. Then you take only this part. Then volume of the first term, 1/3 pi, here radius 2r, square height h, minus 1/3 pi r squared h. Then 1/3 pi, r square take outside. Then here 4h minus h, 3h. Here h by 2, no? H by 2. Then 1 over 6 pi r squared, 7h. Then 1 over 6 pi r squared, 7h mean here 2 times 900 minus r square root. Now simplify. 7 pi r squared over 3, 900 minus r square root. 7 pi r squared divided by 3, 9 minus 900 minus r square root. R in between 0 to 30 given. That's how we obtain. Okay, very simple type. 2019. Now we have to maximize the volume. Then you differentiate this. dv divided by dr. To minimize or maximize both case, you have to differentiate it. Okay, both minimization and maximization identification done by derivative. Then you differentiate, factorize and get zero value. Then differentiate. Seven pi divided by 3. Here r square derivative 2r times 900 minus r square root. Then here product, no, r square derivative times this. Then r square times here the sun derivative. 1 over 2 900 minus r square root times minus 2r. Function of function type. Function of function. Then further simplify. Let's do this say. Here r common take outside. 7 pi divided by 3 r, get common denominator 2 times 900 minus r square minus r square. 900 minus r square root. Further simplify. 7 pi divided by 3r, here 1800 3r square 900 minus r square root, get 3 outside. Seven pi r 900 minus r square root, take minus outside, r square minus 600. Okay, then irrational type function, then after you equate that derivative to 0. Okay, equate that derivative to 0. Then dv divided by dr, dv divided by dr 0, to get maximum value. Then minus 7 pi r over 900 minus r square root, r square minus 600 0, then r square equals 600, r equal 10 root 6. Then here again we get r equals 0 value, but it is wrong, no? There's r 0 value, but you have to remove it because r radius that cannot get 0 value. Then 10 root 6 centimeters. Then you check dv divided by dr sine. So about this region, 10 root 6, 10 root 6 greater than, less than. Then here r value given 0 to 30, no? Then you cut it here and stop at 30. R value in between 0 to 30 value given. Therefore, you have to take that region. Then R value less than 10 over 10 root 6. Here, that is less than 600, then negative. With this one, positive. Here, negative with this one, positive. Greater than value, here positive. With this one, negative. Then plus to minus variation maximum. At r equal 10 root 6, volume is maximum. Volume is maximum. Same procedure, but you have to think little because simplification little harder than previous one. And function type irrational. Previously we have got only rational type, no rational polynomial type we got. Now here irrational type. Complete. Now do 2018 question, 2018. Start 2018 question. Start it. Here the shape. Here radius r. Here radius 3r. Height 5h and h. Phi h and h. Then volume 391 pi. 391 pi cubic centimeters. Then 391 pi equal here pi r squared h plus pi 3r square into 5h. Cancel pi. 391 r squared h 45h. 45 r squared h. Then h equal 391 divided by 46 r squared. Here 17 divided by 2 r square. No? 17 divided by 2 r square. 391 equal 23 times 17. Then now we have to minimize total surface area. Then find surface area relation. Then here open, the other all parts closed. Then surface area S, here pi 3r square times 2 minus here this part pi r square plus 2 pi radius 3r height 5h. Here outer area 2 pi r mean 3r h. Now simplify. Here 9, 18, 17. 17 pi r square 35 RH. 17 pi r squared 35 RH. 17 divided by 2r. 2r squared. 15. 17 pi r squared 15 pi times 17 divided by r. Something wrong, no? 17 part, okay. Here surface area 2 pi r, there's another one. Here 2 pi r h, here 32. Now take 7 pi r, 17r plus 32h. Then find the value of r such that s is minimum. Then you convert that into single variable. (17 divided by 2r squared). Now take 17 outside, put r inside. Then differentiate. 17 pi, here 2r minus 16 over r squared. Simplify. 17 pi 2r cube minus 8 of r squared. Now we can further proceed. Now ds over dr 0, then r cube minus r cube equal 8, r equal 2. Here possible r value. Then ds over dr sine, we have to check less than 2 and greater than 2. Less than 2, greater than 2. Here less than 2 negative, greater than 2 positive. Minimum. R equal 2 centimeters. When r value 2, we get minimum surface area. Two thousand 17 A level question, right? Two thousand 17. Part B. Sketch the shape here it is y x x x x x. area 385 square meters, area 385 square meters, then 385 equal here 2xy 1 2 3 4 plus 3xy 11xy 385, then it is divisible by 85, no? Divisible by 11, 35. Then y equal 35 divided by x. Y value 35 divided by x. Then need to find perimeter. Now here perimeter 2x, 3x, 5x, then here 10x, 10x, 11, 12, 13, 14x. Y 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10y. That is our perimeter. Now remove y, convert into single variable. 14x, 10y, 35 over x. Then 14x, 350 over x. Here given x greater than 0. Now you differentiate. dp divided by dx. Here 14 minus 350 of x squared. Then 14x squared of x squared. Then you take 7 outside. 2x squared minus 50. 25. Take 14 outside. Then solve dp divided by dx 0. (14) x square minus 25 of x square 0. Therefore, x square minus 25 0. X equals 5. No need to write plus or minus because x value positive now. Since x value positive, no need to write plus or minus. Okay. Then check the sign. dp divided by dx sign about 5, less than 5, greater than 5. Here less than 5 negative, greater than 5 positive, minus to plus variation minimum. Therefore, P is minimum when x equals 5 centimeters. Then when x value 5 centimeters, the perimeter become minimum, no? Then you try 2016. Try 2016. Try 2016. alone. Here a cylinder. Here small circular disc has cut. Here radius 5r and here r. Height h in centimeters. The volume of the container 2455 cubic centimeters. Then 2455 equal 5r squared h. 2455 5 square r squared h. Then first cancel 5, cancel 5. 5r squared h. Then take h value. 49 divided by 5r squared. 49 divided by 5r squared. Then surface area. Here pi 5r squared times 2 minus here this whole 5r squared plus here 2 pi radius 5r into h, full surface area. 2 circular discs, remove hole and outer area. 25, 50, 49 pi r square plus 10 pi rh. 49 pi r squared 10 pi rh. 49 divided by 5 r squared. Cancel r 2. Then take 49 pi outside, r squared plus 2 over r. Now differentiate. ds divided by dr, here constant 49 pi, derivative of this, r squared derivative 2r minus 2 over r derivative 2 over r squared. Take 2 outside, 98 pi, r cube minus 1 over r squared. Now you equate ds over dr to 0. ds over dr equals 0 case. Then 98 pi, r cube minus 1, r squared, 0. Then take corresponding r value. Then corresponding r value, r equal 1 centimeter. R cube equal 1, r cube equal 1. Then r equal 1. Then you take ds over dr side. About that 1. 1, 1, less than 1, greater than 1. Then here you check it. R less than 1 negative, r greater than 1 positive. Then minus 2 plus minimum. Therefore, S is minimum at r equal 1. At r equal 1. So when you consider all these question types, so all are simple types, but there are few advanced application of derivative types. There are some advanced type, but past few years we haven't met that type. So all the things are given, all the variables are given, the procedures are given, need to go only along the path. That's it. Okay, continue. 2015 allocation. 2015. Now here it is given a trapezium. Here A, B, X. Then by the Pythagorean theorem, find this A square minus X square root. X square minus X square root. Then area function here BH half into X into H times 2. BH A square minus H square root X square root XH A square minus X square root. Then take this part outside, B plus X A square minus X square root. Here area function. Now further given that A equal root 6. Now substitute. And B equal 4. Therefore X function now 4 plus X A square 6 minus X square root. Now Sx is minimum. Then to minimize you have to differentiate, no? Then just differentiate. Here we have product. Then S dash X 4 plus X derivative 1 into 6 minus X square root plus 4 plus X. Here square root function, irrational one, 2 6 minus X square root times X square derivative minus 2X. Now simplify. Get common denominator. Here 6 minus X square minus 4X minus X squared. Here 6 minus 4X minus 2X square. Get minus 2 outside. X square minus 2X minus 3. 6 minus X square root. Better to factorize this because we have to check signs. No? Then minus 2. 2 factors there. X 3 1 minus plus. Here plus, no? Then here minus plus. Now take d s dash x 0. Let s dash x equal 0. Therefore, minus 2 times x minus 1, x plus 3, 6 minus x square root 0. Then two possibilities, x equal 1 or x equal minus 3. But minus 3 impossible, no? Because x greater than 0. Since x positive, then take only positive value. Remove negative value. Now you check the sign. S dash x sign. Then you consider only about this one. That's enough. 1, 1, less than 1, greater than 1. Then 0 to 1 value, here negative with this one positive. Greater than 1 value positive with this one negative. Then plus to minus maximum. Therefore, at x equal 1, Sx is maximum. Okay, then you come to 2014 question. Okay, then 2014 question, hollow body made by two hemispheres and cylinder. A hemisphere, cylinder, hemisphere. Radius r, height h. The total volume 36 pi cubic meters. 36 pi. Here 4/3 pi r cube pi r squared h. Then obtain h. 36 minus 4r squared over 3 divided by r squared. Then 108 minus 4r squared divided by 3r squared. 3r squared. Then the cost of material for the cylindrical surface 300 rupees. Here cylindrical surface cost 300 per square meters and hemispherical part 1000. Here 1000. Then that means total cost depends with the area. Total cost depends with the area. Then consider cost. Here surface area 2 pi r squared. Here 2 pi r squared, total 4 pi r squared. Cost 1000. multiply by 1000 plus here 2 pi r into cost 300. Okay. Take each hemispherical part and multiply by its cost 1000. Then cylindrical part cost 300. Now simplify. 4000 pi r squared 600 pi r h. Here cost 4000 pi r square 600 pi r, put h here 108 minus 4r square divided by 3r square. Here 600, no? (200 pi 108 4r square divided by r). Take 800 pi 5 r squared (27 over r minus r squared). Now to 800 pi 4r square 27 over r. 800 pi 4r square plus 27r. Here r value given in between 0 to 3. R value given in between 0 to 3. Find the value of r such that c is minimum. Now you have to differentiate that. Still we haven't differentiated. Now here onwards you have to differentiate. Here you have to minimize cost. Need to minimize cost, then differentiate. Then dc divide by dr 800 pi, here 4 times 2r minus 27 over r squared. 800 pi 8r cube minus 27 over r squared. Now dc over dr 0. Then 8r cube equal 27, r equal 3 over 2. When r equal 3 over 2, that happened. R equal 3 over 2, that happened. Then you check dc divided by dr sign. Then about this value, you check the sign. Here r not more than 3, not less than 0. Then r value in between 0 to 3 region. Now check the sign. When here r value less than 3 over 2, definitely this get negative and positive. Negative to positive, minimum. Therefore at r equal 3 over 2 centimeters, cost is minimum. Cost is minimum. Cost is minimum. Okay. Then you go to 2013. Now 2013 question, 2013. Here the shape. Here 4x, 2x, 2x, y, x. Now area 800 meters, square meters. Here 2xy, here 2xy double x into 8x. Then 200 xy 2x squared. Then y equal 200 minus 2x squared divided by x. You take 2 outside. 100 minus x squared over x. So here in accordance with x, y value can be negative, no? But definitely you have to know xy both positive. They are size length, no? Then y greater than 0. Then 2 times 100 minus x squared divided by x greater than 0. Then here 2, 10 minus x, 10 plus x. Divide by x greater than 0, take minus outside. X minus 10, x plus 10. Greater than 0. Then remove minus. X minus 10, x plus 10 of x less than 0. Then corresponding x region, here 10, 0, minus 10. Here negative region is this and this. But we know x positive, no? Since x positive, x in between 0 to 10. That happened for x in between 0 to 10. Still we haven't done differentiation, but you have to analyze that one. Okay. Now write perimeter. Write perimeter. P equal 16x plus 2x plus 4y. 18x 4y. (18x 4y) y equal 200 minus 2x square divided by x. 800 of x plus 10 of x plus 10x. 10x. Now that function known, then you differentiate that one. Differentiate it. Okay. Now you take that perimeter function and differentiate. Take that perimeter function p equal 800 of x plus 10x dp divided by dx minus 800 of x squared plus 10 x square minus 80, then dp over dx 0, x square equal 80, x equal root 80. For root 5 in meters. For root 5 in meters. Now you check the sign. dp divided by dx sign about that x value. For root 5, for root 5 greater than, less than. So here that not less than 0, that not greater than 10. So within that region that must happen. Then here less than 80 negative, greater than 80 positive, minimum. Therefore P is minimum at x equals 4 root 5 meters. At x equals 4 root 5 meters. Complete. Okay. Then application of derivative part enough for now. So you do further questions in past paper set. So we have to do another level. We have to do another level. But for now, for our A-level standard, this is enough. Okay. But later I do few questions. That mean getting variables and selecting variables and function development part. Okay.